Okay, structural formula, you know the valency of carbon is always 4. So C will be there and these will be 4 hydrogen atoms.
And the electron formulas where basically you just do dot and cross diagram of the same representation.
Correct. Okay, wherever one line, that is one bond is there, that's a single bond, there will be 2 electrons. So when you are drawing electron dot structure, okay, dot will be there, cross will be there, dot, cross, dot, cross. This is going to be the electron dot structure. This will be for methane.
And so after ethane, what comes? Propane?
1 minute. First compound is methane, second one is having 2 carbon atoms, that is ethane. You need to know the names of first 4 compounds of each of these homologous series. Okay, here the formula will be C2, count the number of hydrogen atoms, double, 2 to the 4 and then plus 2, that is H6. If you draw the structural formula, always valency of carbon is 4, this will be the 6 hydrogen atoms.
Oh, 6.
Okay, I just want you to, pardon?
Can you please not record?
Yeah, I am recording it. Okay, the next compound.
No, I know that you're recording. I don't want you to record. It makes me uneasy.
Yeah. Now I want you to draw the third carbon atom. The third one of this is propane. Write the.
Okay, it's propane.
Write the molecular formula first.
Yeah. C H H H A.
Correct. Now draw the structural formula. All 3 are carbon atoms, and then rest all will be hydrogens. Okay, wherever single bond is there, you will show the pair of electrons. The 4 carbon atom compound, what is it known as? What will be the 4 carbon atom compound known as?
Butane.
Correct. This is butane. What will be the molecular formula? C4H. Okay. 4 to the 8, double plus 2. And the structure also will be similarly, just all 4 carbon atoms in straight chain. Rest all will be hydrogen atoms. This was applied for alkanes. We'll go for alkenes now. It is ending with ene, it means there will be a double bond.
Propane, butane.
We'll have only 3 compounds over here, up till first 4 carbon atoms. Okay, the general formula will be CnH2n. It means the number of hydrogen atoms will be just the double of number of carbon atoms. There is no C1 compound because to form a double bond you need at least 2 carbon atoms. So it will start directly from 2 carbon atoms. So the formula of this is going to be C2. Number of hydrogen atoms will be simply double. So it's going to become 4. Now the structure. This will be the structure of the 2 carbon atom compound. Because it is an alkene, its name will be ethene. Now the 3 carbon atom compound, that will be propene. Its molecular formula will be C3, hydrogen atoms 3 to the 6. So show 3 carbon atoms in straight chain. At one place there will be a double bond.
So
How many? Yeah,
can you please check your phone?
my phone. Okay. So you click something and send. Okay, no problem, no problem. If you want, you can simply draw and just send it to me if you are not able to speak. Yes, now tell me how many hydrogen atoms will come on this carbon atom?
2. 2.
Correct? Because valency of carbon is 4, 2 bonds are already over here. You can show up or down any one of these bonds. These 2 hydrogen atoms will come over here. On the second carbon atom, how many hydrogen atoms will come?
One.
Yes, only 1, because 3 bonds are already there. Either you can put it up or you can put it down anywhere. Over here there will be 3 hydrogen atoms. This will be the structure of propene. The last one. Okay, 4 carbon atom compound. That's going to be butane. Okay, so here 4 carbon atoms are there. Alright. Now here there are 2 possibilities. Either the double bond is between the first and the second carbon atom, or the double bond is between the second and the third carbon atom. Of course, this possibility is not there because then I'll start counting from right hand side. These both will have same formula. The molecular formula of butene will be C4. Hydrogen is double, so 4 to the 8. C4H8. They will have same molecular formula, but you see their structures are different because the double bond location is at different places. Such compounds which have same molecular formula but different structural formula, we call them isomers. I can simply count how many bonds are there and accordingly I can put hydrogen atoms. So 2 are there, so 2 more bonds with 2 hydrogen atoms. Here only 1 hydrogen will come. Here 2 hydrogens will come. Here 3 hydrogens will come. In the second isomer, 3 hydrogens over here. There will be 1 hydrogen, here also 1 hydrogen, and again over here 3 hydrogens. IUPAC nomenclature. First, initially, I'll just give some names, and we are supposed to draw the structure. Suppose if I give you 2-chlorobutane. I'm supposed to draw this structure. Just try it out on your own, and you can send me the pics.
2-chlorobutane. Butane. So, it's disappearing. Yeah. Not hunger. So are you erasing it? So it's going.
You got it? Have you sent it?
I'm trying to I'm trying to annotate on your screen.
Okay, just wait. Yeah.
And it
All right,
keeps
I got it.
Two chlorines, are they two chlorines or the chlorine?
No, 2-chloro means the chlorine is attached to the second carbon atom.
Or
Okay, anywhere on the top or bottom you can show. Rest all are hydrogen atoms.
yeah.
Okay. If you use a USB mouse, then that will be more better than this one.
So
Let's go to the next.
all the alkenes till 8, then all the alkynes till 8, then I'll send it to you.
Okay. All right, but then if you are writing alkenes up till 8, then you have to consider all their isomers also. Isomers also, yes.
How do you know how many isomers can be produced?
So that you will have to actually draw it and do it. Yes, you can draw that.
Oh, I have to draw it. Two, two. What does this 2 mean?
See, first of all, dibromo. It means there are two bromine atoms attached.
Yeah.
2 means both the bromine atoms are on the second carbon atom.
Okay, fine.
It's butane, so parent chain will be of 4 carbon atoms. First you draw both bromine atoms, it's on 2, 2. Yeah, that will be BR. Okay, that's understood.
And this is
Yeah, just draw those lines, it's understood that rest all are hydrogen. Yeah. Okay, next example.
so in pentene, can there be pent 1-ene, pent 2-ene, and pent 3-ene?
You can't have pent 3 in. Pent 1 in and 2 in are possible. Why? Just see this. These are 5 carbon atoms.
Yeah.
Okay. If I draw the double bond over here, this is pent 1 in. If I draw the double bond over here, it's between second and third carbon atom. This is going to be pent 2 in. If I draw the double bond over here, then I'll start counting from this side.
Okay.
In this case, it is going to become pent 2 in only. Okay. But still, anyway, branching is not there in your syllabus. You can branch also. You can have another branch of carbon atoms like this. No, but still,
Hex 1-ene, right?
no.
No. There's no hex 1-ene.
See here, the molecular formula is going to be C5H10 in both the cases. But here, there is branching of carbon atoms and the double bond is also located at different places. What will be the IUPAC name of this compound? Over here, I'll start counting from this side. 1, 2, 3, 4. Okay. This group which is there, here also CH3 will be there. There will be 3 hydrogen atoms attached like this. So this whole group is going to become methyl. So this is going to become 2-methyl. Okay. The longest chain is of 4 carbon atoms only. So that will be but 2 in. This if I am considering, I'll start counting from here because double bond should be closest. This is going to be, the methyl is attached, H3 is on the, CH3 is on the third carbon atom. So this is going to become 3-methyl. But the double bond is between first and second carbon atom, so 1. These all will have molecular formula C5H10 only. So these all will be considered as isomers of pentene only. The only thing is that here branching is there. But still branched isomers are not there in your syllabus. This is the extra additional part that we have done.
It's not there in the syllabus.
No. Branched isomers for IUPAC, they are not there. Now I'm just going to do other way around. I'll give you the structure, you give me the names of what will be the IUPAC name of that particular compound.
Yeah. So I just wanted to ask, is hex 2 possible?
Hex?
2E.
Yes, obviously. Hex 1 in, hex 2 in, hex 3 in are possible. Hex 4 in is not possible. Because then you will start counting from the other side.
Okay.
Yes, give me the IUPAC name of this compound.
It's pentane at the end.
Okay. 5 carbon atoms are there, longest chain. So it is pent. Single bonded. So AN.
Pentanol, because OH is there.
Okay. You also will have to give the position of OH group. What will be the numbering or position of OH group?
2.
Correct. You start counting from right hand side. First carbon atom, second carbon atom, and 10 to all.
You write
Or
this pen 2 and all.
no. That's wrong. It should be pentane to all, or you can write 2 pentanol.
Okay.
The next one.
So it's hexane. It's dichloro.
What about numbering? Numbering. You have to give the position of chlorine atoms also.
2, 3.
It will be 2, 3,
3,
3.
di, tri. Okay, like that. um, how do you, um, one
Hmm.
and one. You have to if you have to count only one way, right?
Yes, you can't count from both the sides.
Okay, so it's 1, 1, 2, 2, 4 bromo, ethane.
Okay, there are 4 bromine atoms. So when 4 are there, tetra bromo, there are 2 carbon atoms. The next one,
Um, this is carboxylic acid, right?
that's right. This group which is there, okay, COOH. This is carboxylic acid.
Okay. So how do you say it in words?
Carboxylic acid, wherever it is there, it is always going to end with pic acid.
Okay, so
Now you just count how many carbon atoms are there. This is 1,
so
2,
butyric acid.
3, 4, 5 carbon atoms are there.
Oh, so
So this is going to become
pentanoic.
pentanoic acid. Then we have nomenclature of esters.
Ester.
First I'll just give you one reaction. Now this part is alcohol part. And this part is carboxylic acid part. What is the name of this alcohol?
It's propanol.
Just one sec. Yeah, okay. Mm-hmm. Yeah. What is the name of this alcohol?
This is butanol, and this is
No, it's not butanol.
sorry, propanol.
Okay,
This
it is propanol.
ethanoic acid.
Okay, 2 carbon atoms are there.
So there will be propyl ethanoate, right?
Right. Alcohol part is always alkyl
How
part.
do you find them?
Yes. How am I going to draw the structure of these ester? I am going to use over here concentrated H2SO4, which is going to act over here as a dehydrating agent, which is going to make the reaction faster. Okay, always the acid part is going to release hydrogen H plus, and the alcohol part is going to give OH. These H and OH, that's going to become H2O, which I am writing over here. Now this part which is there. Okay, first I'm going to draw this part. See, there is no H from here. So I have removed that H part from there. Okay, the H part is gone. I have drawn over here. This part is drawn again. And this remaining part which is there, that gets attached to this carbon atom. Okay, so this part is O. This H is gone. And this whole part which is there,
So you take the OH from the alcohol, you take the H from the carboxylic acid.
yes, that I'm going to attach over here. Okay, this part which is there is propyl, and this part which is there is ethanoate.
So you made it ulta.
Always the carboxylic acid part which is there, it is going to be alkanoates, ethanoate, methanoate, and so on. While the alcohol part which is there, it will be alkyl part, that will be methyl, ethyl, propyl, etc.
I'm
Okay.
getting confused. Can you show me again where exactly you have to cut off the? Oh,
Where is?
like I'm getting confused.
Should I explain it again?
Yeah, please.
Okay, I'll just take another different example because anyway I'm recording the class. You can just review it again. Yes. Now suppose the next different example that I'm taking. The first part over here is alcohol. Give me the name of the alcohol.
This is ethanol. Yeah, ethanol, and this is butanoic acid.
Correct. There are 4 carbon atoms. The conditions for the reaction will be same. Concentrated H2SO4 which will be acting as a dehydrating agent. Okay. Now over here, these H and these OH will go away. So what I'm going to do over here is I'm going to remove this part. First I'm going to copy down this part with oxygen included.
So you only leave the H.
Yes. Only H part is left out. I've just copied the whole thing again over here. Okay. The H part is left. This H is gone. This OH is gone. That becomes plus H2O, which is removed by the dehydrating agent like concentrated H2SO4. That's sulfuric acid. The remaining part which is there, this whole part which is there, that gets attached over here.
So the H from this, wait. So the H from here, it
Yes.
goes, and it joins oxygen.
Yes. This part will get attached. That's why I'm rotating it.
Oh, okay, fine, got it.
Got it? So that is getting attached over here like this. Now the name of this compound. The alcohol is always
Butanoid.
correct. This part is your ethyl part. This part is your butanoid part. Okay. I'm giving you one more extra additional question. You just try to work it out on your own.
Yeah. So just 2 minutes. Somebody's calling me. I'll just come.
Yeah. Just click the picture and send it to me. I'll just do the correction. Just 1 second. दरवाजा बंद कर दो. You have not drawn the. Wait 1 second. You have not drawn the structure of methyl ethanoate. Yeah, okay. So you have not drawn the structure of methyl ethanoate. Okay. I'm just going to show it to you over here. Now this part from here H is going to go. This is OH basically. So CH3 will remain as it is. This C is there. Double bond O is there. And this O is there. Okay. From here this H is gone. Now from here this OH is gone. That is going to become H2O. What is remaining from here? CH3. So this part you are going to attach to the remaining portion. So C will be there, and then these 3 hydrogen atoms will be over here. So this part is your methyl, and this part is your ethanoate. Methyl is over here. This part is ethanoate. Okay, because methyl part which is there, it comes from alcohol, that is methanol, and this ethanoate part which is there, it comes from carboxylic acid, which is ethanoic acid in this case. Right. I'm just going to give you one more example. You have to work out the same thing as we have done for the previous part. Yeah, okay, no problem.
I send you the pic.
No, it hasn't come. It's not come yet. Yes, now it came. HCOOH. For this carbon atom, this hydrogen is there or not there? If it is not there, then it is wrong. Because this hydrogen is supposed to be there. Okay, C double bond O and this O, so this H has to be there. Here there are only 3 bonds, double bond with oxygen and 1 bond over here. So this H has to be there, it is correct. If this H is cancelled, then it is wrong. Otherwise it's right, butanol and methanoic acid. Okay, so this H has to be there. That is this H only. Okay.
But sir, there's a double bond here, there's a bond. Okay, fine, got it. Yeah,
But where will this H go? This H is going to remain like that only. This whole part is going to remain as it is. Only this H will be gone from here. And this OH is gone. This H has to be there. So that was about IUPAC nomenclature. Some other additional things that I'm going to do with you is what are addition reactions, what are substitution reactions.
So can we just not the whole thing in one day? Because I'm pretty sure I'll get
Yeah, no problem. Then we'll do it later.